at Farnborough International Air 2024. Great live stream on the latest and greatest in hydrogen aviation. So Glenn, welcome.
Thank you, Val. Great to be at the air show.
Absolutely. So we just participated in the sustainability presentation that you had at Airbus, and great comments there. So maybe you can give us a summary of what's greatest and what's the latest you're working on.
Sure. I think the activities that we've been most focused on cover three main areas. One is on the ecosystem, where we know that we need to develop the ecosystem. Decarbonized hydrogen needs to exist in the future in large quantities at airports. We also have to work on the technology, developing the technology, making it lighter weight, making it more power dense, so that we can have, for example, fuel cell engines on our future aircraft. And there's also a lot of work that we're doing in understanding the climate science of hydrogen propulsion system in flight. So we've already been flight testing hydrogen combustion and simulated fuels in flight and sampling the exhaust with a chase aircraft in order to really build up I think the best in the world understanding of the climate impact, and hopefully close to zero climate impact of the different propulsion systems.
Yeah, no, really, it was great since I think 2020 when you've announced officially the ZeroAvia program, and we're really the first airframer, and that's the world's largest airframer, to announce the commitment to hydrogen. And since then, of course, a lot of great things happened. What are your biggest learnings from the journey, like in terms of how realistic it is to see these technologies in the air soon? What, if any, technological changes that you had to make, maybe some of those?
Sure. I think one of the biggest learnings from the announcement we made in September 2020 is that, first of all, that announcement was super necessary. We don't usually express so early in the aircraft development cycle the ambition that we've done. And needed to do that because we need a partner ecosystem, we need a regulatory ecosystem, an energy ecosystem to work with us at the same pace as us in order to create the conditions of success. So the first big learning has been how important that's been, and how the response has been really positive. We've got partnerships across the US and Canada, Europe, Asia, Australia, and those partnerships have been enabled by us open and communicating the ambition, and then sharing that ambition with a wider ecosystem. And the variety of partners is super interesting. We've got energy providers, we've got airports, we've got airlines, of course, and beyond that, we often have political stakeholders, people who can influence the regulatory system in a positive way so that we can be successful on this adventure. On the technical side, we've made a lot of learning. We've most of it actually super positive. One really good recent example has been the ground testing we did looking at the fuel cell engine, and in particular how reactive it is when you apply full thrust from idle. Our ability to go from idle to full thrust in a very short amount is super important because there's a certification requirement. We need to be able to do that within 8 seconds. We succeeded in being able to do that in 6 seconds, and on a certifiable architecture is a really important demonstration that this kind of technology is capable of meeting the kinds of certification requirements that exist on today's aircraft. And that's on a first iteration of an engine that we're ground testing. That's not even the optimized version, which we're then going to iterate through and get to in a few years. So, really learning that, this is hard for sure, but once we focus on achieving different requirements that are going to be super important for us, actually with the right creativity and talent, and of course investment, we can make it.
Yeah, so ZeroAvia, of course, is looking at multiple types of hydrogen combustion, hydrogen fuel cells, multiple types of hydrogen propulsion. How do you think about all of those with respect to each other, especially based on the learnings that you had? So it sounds like really good experience with the hydrogen cells at megawatt plus level. So tell us more about how you think this will be applied to different sizes of aircraft.
Yeah, so we're doing some flight testing at the moment, looking at hydrogen combustion in flight. It's what I mentioned, where we put the chaser aircraft behind an aircraft with a hydrogen combustion engine. We're also doing the same thing for a fuel cell aircraft, and that highlights, I think, some of the learning that we want to gather in order to allow us to understand better the climate credentials of those two different types of propulsion systems. We're also clear that at least in the first generation of fuel cell technology, fuel cell propulsion technology, that there's likely to be a limit, whereas a hydrogen engine propulsion system is perhaps more scalable. So in the first generation of technology, that's the sort of that we're seeing. In the second generation of fuel cell technology, where we go to high temperature PEM, high temperature fuel cell stacks, where we go to perhaps cryo-cooled electrics. Cryo-cooled electrics is where you use what you've already got on board, which is cryo temperature with hydrogen at minus 253 degrees C. You use that to cool down your electrical system. That brings the resistivity in your electrical system close to zero, and so you can carry a significant more amount of power without adding really extra weight to the aircraft. And so the second generation of fuel cell propulsion system, that really has the potential to have the scalability and maybe even compete with hydrogen combustion in terms of scalability. So I think it's key right now not to make quickly any decisions. It's important to push all of the technologies to their limits, and then once we have a clearer, better understanding from all of our flight test, ground testing activities, then we'll be able to, in a calm, non-emotional way, make some of the big decisions about what we take ultimately to the next phase of demonstration and commercialization.
Yeah, basically let the data speak for itself, push the technology. Yeah, so we are, of course, at ZeroAvia, we're excited about hydrogen fuel cells, and we think that it would be great to get away from combustion altogether, right? Because I think you spoke as well around non-carbon effects of aviation and how it's. Speaking of that, frequently asked question is, well, why don't we just do it with SAF? That thing works, and we can just use it today already in the existing vehicles, existing engines. So why not just do it and forget about all this new tech?
So SAF is a really great solution right now. All of Airbus's aircraft are compatible with sustainable aviation fuel today. It's a drama, in my view, that we're not using the technical capability of the aircraft to carry much, much more sustainable aviation fuel. And we're focused on bringing the technical capability of the aircraft, which is today 50% blend of sustainable aviation fuel is acceptable, all the way up to 100% SAF compatible by 2030, with the intention to make sure that our current products are never a bottleneck in the scale-up of sustainable aviation fuel. And today we have to recognize that that's what can have a climate impact reduction significant. This looks like it's starting to go off. I don't know, did I press something or no? It's okay. So that's what can have a significant impact today in aviation, and we need policymakers, we need the fuel producers to be, in my view, much more engaged in increasing the amount of sustainable aviation fuel. And then your question is super valid. So if we've got this sustainable aviation fuel, why are we focused on hydrogen? And hydrogen is complicated, right? It requires a new aircraft development. It's not compatible with existing aircraft. We have to change the airport infrastructure. We need to get hydrogen available at airports. And really the carrot for us, the prize of flying with hydrogen is to be able to really get extremely close, if not achieve, zero climate impact. sustainable aviation fuel goes a long way. It's really good. We should be using it today, but hydrogen is even better. And in Airbus's view, when we consider what societal expectation will be in the 2030s, 2040s, we see it as a huge opportunity to be able to offer the kinds of commercial aircraft solutions which could be allowed with hydrogen. So for us, they're complementary. It's not likely that we're going to be covering long-range operations anytime soon with hydrogen. So sustainable aviation fuel and hydrogen have a place in the future market. What's also likely to be helpful in the context of hydrogen and sustainable aviation fuel is that sustainable aviation fuel may be limited in terms of quantity. And so if we can bring hydrogen solutions, we can also ease the pressure on the sustainable aviation fuel ecosystem. And I think that's great for everybody. So in our view, it's sustainable aviation fuel and hydrogen, they're very complementary. And in fact, most of the sustainable aviation fuel that we'll be using by the time we get to 2050 will be hydrogen-based sustainable aviation fuel. So we need masses of decarbonized hydrogen for the future of aviation.
Yeah, exactly. So this is one of the messages that we are hearing more and more, that no matter what avenue you take, aviation will need a lot of green hydrogen. And whether that hydrogen is used as combustion or fuel cells or to produce sustainable aviation fuel, e-fuels, we need to all agree that we need a lot of hydrogen, like green hydrogen, well, zero emission, ideally green. So we need to invest more as a society into green hydrogen production. Now, speaking of investment, I think you also announced Airbus an investment in LanzaJet. So great to see these types of investments. Is that a sign of what's to come from Airbus? Maybe investments into more of the infrastructure players and maybe on the hydrogen side as well?
Yeah, so maybe to talk a little bit about investment, I think it's part of Airbus really putting its money where its mouth is. We're saying that we need to change the ecosystem. We're saying that we need to drive a positive increase in all of these decarbonization solutions being available. The LanzaJet investment that you mentioned is specifically focused on sustainable aviation fuel. We've announced in the past an investment in HY24, which is a hydrogen infrastructure investment, and that's super important to allow the scale of the hydrogen ecosystem in aviation, but also beyond aviation, because we see that as really important for us, that the wider hydrogen ecosystem develop. And of course, we invested in ZeroAvia. And why did we do it? Because we think it's only a positive thing that we have several players developing the technologies, developing the ecosystem to allow the kind of future that we are pushing for at Airbus.
Thank you. Appreciate the trust, and definitely thank you very much for the investment support. Not only us, but also the rest of the ecosystem. That's super important. So to make the ecosystem work, the government side needs to be taken care of as well. The policy, aviation is a global industry, so we are seeing proliferation of sort of local policies between the US, UK, European Union. There's all different SAF mandates, different views on hydrogen. What do we need from the regulators? What do we need from the governments?
The first thing we need from regulators is definitely stability in the medium term in terms of the incentives that are going to be put in place for aviation, but even for the wider ecosystem. I just mentioned how important the wider ecosystem is for what we're trying to do here with aviation. If, as has been legislated in Europe, for example, 620 hydrogen refueling stations across the European 10T road network, if that legislation now gets fully implemented in concretely deploying refueling stations at that quantity across Europe, that's going to mean the bridge that we need to make in between the wider hydrogen ecosystem and aviation is a relatively short bridge, because there's going to be a hydrogen refueling network already existing across Europe in that example. And we need to see the same things happening in the wider renewable energy hydrogen ecosystem in the UK, in the US, in Asia, in Canada, etc., etc. We're interested in a global market, so it's super important that we continue the pace that's already been started in terms of hydrogen ecosystem deployment. We also would like to see a continuation in the support that we get from public funding bodies. We need to advance the technologies required to commercialized zero-emission flight possible. Those technologies we're taking from, often from the automotive industry, taking from the space industry. We're increasing the performance of those technologies. Those technologies will find themselves back in the wider industry. So in our view, investing in aviation is a way to create a competitive edge in our national ecosystems on these technologies, which will have a circularity back into the wider industry. And we're very proud to be supported by many of the nations inside which we're working to be able to achieve the ambition. And of course, we need regulatory standards. The incentives like mandates on fuel types is a super important first step, and we need to see the approach continuing, but in a consistent way without some of the back and forths of the political winds of change.
Yeah, of course, there are a lot of winds of change here, but hopefully, being the global industry, we get to ride the momentum overall in the world. Yeah, and I think the momentum is towards the clean aviation. It's a great prize there because I think we agree both that aviation philosophically is a great thing for the future, great thing for the world, connects people, connects businesses. We can't just stop flying because we wouldn't have the gatherings like this, exchange ideas. And there was a short period of time when during the pandemic people thought that, hey, we can do everything on Zoom, but it's not really a reality. Yeah. So really exciting to see all this momentum, and in fact, some of the really bright projections out there say that hey, by 2050 we might have 25 to 50% of all flying be zero emission or hybrid. How realistic do you think those projections are?
I think the first focus has got to be for all of us to get the technology, get the ecosystem into place. In my view, once we do that, I think society, airline passengers, customers, everybody is going to want this. This is the best way to physically connect long distances. And so I think we're going to see a massive take of these kind of products as we go into the next decades.
Glenn, as always, great to have you, and thank you for your support, not only for us, but also for the rest of the system. I think it's super critical for the whole world.
Super. Thank you, Val.
All right, do we have any questions from the audience or the live stream?
Thank you. Aviation Week. Can I ask how important it is to begin actual demonstrations in terms of flight demonstrations of hydrogen-fueled aircraft as part of this growing inertia and building up, the sort of enthusiasm for it?
Yeah, it's super important. It's important for several reasons. The first reason it's really important technically. We need to demonstrate that we can do this, that functionally it operates, that from a performance perspective it operates, and that we're managing the safety in the right way to enable this to happen in the subsequent steps. So technically there's a huge interest in bringing all of the different technologies we're looking at into a real environment. You can do a lot on ground. Here we're talking about taking altitude, bringing it through pressure cycles, different temperature regimes, and that's super important to expose as early as possible our systems to those kinds of environment. Like I mentioned, we've been doing some testing already with hydrogen propulsion systems, and we've got more and significantly bigger testing planned over the coming years. So yeah, really, really important. I think the other reason it's super important is beyond the technical, and is I think lots of people are thinking, is this really possible? Is this cryogenic hydrogen, minus 253 degrees C, hydrogen? People think of safety concerns. People think of the complexities. And I think it's important that people see a demonstration of it really happening, just to confirm that this is a trajectory that's super viable, and to reassure people that it's a good option for the future of aviation. So I think there's certainly those two aspects which are really important.
And a question from the floor, which could be for either of you, from the live stream rather. So Paul Pereira asks, how do we get green hydrogen to be cost competitive?
I can maybe start. And, at ZeroAvia, we have generated our hydrogen on site for our flight test operations. So we know a thing or two about bringing this together for the actual renewable hydrogen generation. Today, the technologies are on the electrolysis side specifically are in the beginning state, mostly around actually how they're put together. Speaking at some other event on how we saw these things ourselves being put together by hand. And while the underlying technology is solid, the production processes and the scale is not quite there. But that means that we are going to see the same type of trajectory as we saw in photovoltaics, solar cells, or wind production over time. And we saw that orders of magnitude improvements to the point that now the cheapest power plant to build is a renewable power plant. So we're going to see the same type of trajectory very, very soon. We've done a great deal of modeling and exercise around that for the actual airport locations where we plan to have operations. And we have shown that in many, many cases, we can get hydrogen at a level that will allow us commercially viable operations on these small vehicles very early on. You have to remember that for the small aircraft, small turbines, the efficiencies are very low. They're in the 20%, 22, 25% for the 10, 20-seat aircraft, and this is our first commercial target. For those, it's relatively easy to get hydrogen at $6, $7 a kilo. That would already be cheaper on a per seat mile basis than operating off of the jet fuel. I know, Glenn, if you have anything to add from your perspective.
I think that's totally valid, and then the wider exercise throughout all of the industries and teaming up at this stage with many of those industries to increase the scale effect, increase the quantities, super important in all of this.
Any further questions from the floor? In which case, we can wrap up.
Yeah, well, thank you very much, Glenn. Again, great support for the ecosystem, super important for the world. I think ZeroAvia, Airbus, all of the other partners will bring the future to aviation, and we need as many partners, as many people as possible join us in this endeavor. Thank you.
Super, thank you.
Next follow. All right, let's go. We roll.